Chapter 9, Chemical Bonding 1. There's more than one chapter about chemical bonding. So in this chapter, we're going to talk about the Lewis model. Silly thing. Here we go. Okay, so back in 1989, HIV was a big deal. It was relatively new, and people were very anxious to figure out how to treat it, how to cure it. So in 89, the structure of HIV protease was determined. This is a protein that's synthesized by HIV and is necessary for it to reproduce. So the researchers were able to design several different molecules that could disable HIV protease by binding to the active site. Enzymes work in that they have a bonding site and they bond with specific molecules and catalyze specific reactions. So if you get a molecule that'll go into the binding site and stick there, then you can disable the enzyme and it can't do anything. So you can essentially shut it down. So they were able to design these molecules using bonding theories that simulated the shapes of potential drugs. Sometimes drugs are discovered by accident. That's how, people knew that slippery elm bark and different things would cure illnesses. You wonder who was so desperate that they went out in the woods and started chewing on the bark of trees. But that's how a lot of things were found. Other times, it's not exactly random, but you just try different things and see if it does any good. This is more targeted. We have a specific thing we want to do, and we can look at the shapes of the molecules to help us narrow down the list of things to try. So protease inhibitors were discovered. They do not cure HIV, but they shut down that enzyme, and so they can reduce the viral levels to undetectable levels. So as long as you take the protease inhibitor, the HIV is dormant. And so that's a really good thing. So how do we know what the shape of the molecules are? This comes in large part from bonding theories. Bonding theories explain how the different atoms bond together to form molecules. This helps us to understand why some molecules are stable, others are not. They help us to predict the shapes of molecules. And shape of molecule determines a lot of chemical and physical properties of the compound. There are different bonding models. There's a trade-off between predictive power and complexity. So you can have a very complex model, which is very difficult to use, difficult to understand, and that's going to do a great job of predicting stuff. But you don't always need that. So there are also more simple bonding models that work in many situations, but not all situations, and give limited predictive power. And so there's a trade-off. You can be more predictive, but then more complex. So the Lewis model is the simplest one, and that's the one we'll start with. Valence electrons are represented as dots. We've talked about valence electrons before. Those are the ones in the highest principal energy level. And we can tell for the main group elements how many valence electrons they have by what group number they are in the periodic table. So we represent the valence electrons as dots. They have a lot to do with bonding in molecules. So we draw Lewis electron dot structures, or sometimes just Lewis structures, to illustrate molecules. It helps us to predict the shape of the molecule, helps us to predict if the molecule is stable.